Mars exploration is moving from short robotic missions towards permanent operations. And with that shift comes new challenges. Rovers have been invaluable, but they are limited. They move slowly, they can't easily navigate cliffs or craters, and they struggle to provide the kind of wide area coverage and maintenance support that long-term human presence will require. If we want to build and sustain facilities on Mars, we need something more agile, more versatile, and more autonomous. That's where aerial drones come in. NASA's Ingenuity helicopter proved this was possible. Originally planned for just 5 flights, it completed 72, showing us that powered flight is not only feasible in Mars' thin atmosphere, but also highly effective. Future aerial drones will build on this by carrying heavier payloads, surveying larger regions, and even performing infrastructure inspection and repair. Different types of drones will serve different purposes. Fixed-wing drones are ideal for long-range mapping and large-scale surveys because they can capture images of vast landscapes. Rotary-wing drones, like helicopters, excel in close inspections and confined environments. Hybrid platforms combine both strengths, offering flexibility for diverse missions, but they are more complicated and expensive to produce. Together, these systems can explore lava tubes, monitor construction sites, inspect habitats, and respond to emergencies, tasks that would be dangerous or impossible for astronauts alone. Maintenance-minded industries are looking at how aerial drones can handle a physical workload. The AeroFarms project, originally designed for industrial inspections on Earth, demonstrates how UAVs with dual robotic arms, multi-directional thrusters, and advanced control systems can perform precise contact tasks despite disturbances. The real game changer, however, is swarm technology. Instead of relying on a single vehicle, we can deploy fleets of drones working cooperatively. ESA's Pangea X trials show that swarms reduce operator workload and provide resilient coverage, even in hazardous terrain. By distributing tasks, swarms improve efficiency, adaptability, and mission safety. They can scout resources, survey vast regions, and even conduct simultaneous maintenance checks across multiple outposts. Artificial intelligence is the key to making this work. Because of the 2 to 22-minute communication delay with Earth, drones must be able to make decisions on their own. AI will allow them to navigate difficult terrain, adapt to unexpected problems, and reassign tasks among the swarm dynamically. It will also support human-drone collaboration, ensuring astronauts can focus on high-level mission planning rather than micromanaging every flight. Looking ahead, these systems will not just complement rovers and orbiters, they will become essential. Drones will extend our operational reach, reduce risk to astronauts, and ensure that critical facilities remain functional in Mars's extreme environment. In short, aerial drones, swarm robotics, and AI are not optional add-ons. They are the future of Mars exploration and the foundation of safe, sustainable human presence on the red planet. Thank you.